doing today is that we're going to be going over density. Now, you guys have a problem set on Google Classroom on density, but before you guys work on that problem set, I want to just review this and think about also how you incorporate density and conversion factors and significant figures as you're working through problems. So to illustrate this, I want to work through probably a little bit more tricky problem than what you'll see in your homework, but hopefully this will give you a starting point in which to start the problems. So we have here someone that's walking around and they have a hypothesis that the earth is made entirely of granite. To test this hypothesis, they have a piece of granite that they're going to weigh out in their bathroom scale. They know the size of it, the cubic feet of it, and they're going to compare the density they get with the density of the earth. Obviously, if the density of the granite and the earth are the same, they've proven their hypothesis, and if they're different, they've disproved their hypothesis. So let's look at this problem. Now, if you guys remember from earth science that the formula for density is D is equal to mass divided by volume. In this problem, we're solving for density, so we can use this formula as is. But if we were asked to find mass or volume, we would have to rearrange this formula. So what you also need to remember is that density is over 1, and if we're rearranging this formula, we would cross multiply, and to get mass, we would have mass is equal to density times volume. And if we were looking for volume, we would have to divide each side by density to get volume is equal to mass divided by density. So we can rearrange this formula to solve for whatever we need to solve for, but remember in this problem we are looking for density. So we're going to plug in the information, but remember we have our volume is equal to 1.5 cubic feet. We have our mass is equal to 256 pounds. So we're going to solve for density by dividing the mass by the cubic feet, which is the volume. So when we do this, we're going to get 171 pounds per cubic foot. So now we want to get this into grams per cubic centimeters. Now I could do this in two ways. I could convert everything using a string of conversion factors, or I can convert the 171 pounds into grams and that 1 cubic foot into centimeters cubed. I'm going to do it the second way just so you guys can see that process. So I have 171 pounds, and I'm going to convert that into grams. So to do this, we're going to have to go back to our table of conversions, of equalities from our worksheet that we worked on last time. I would not expect you guys to know all those conversions between the English and the metric system, but I do expect you to know the conversions within the metric system. So let's go back to that sheet, and we see that 1 pound is 0.4536 grams. So that's what we're going to be using here to help us. Okay, so we have 1 pound is 0.4536 grams, or no, kilograms. Just double check. Yep. And then we have now kilograms, so now we're going to go to grams. Now remember, kilograms is going to have to go on the bottom, and 1,000 grams would go on the top. Notice here, pounds cancel out, kilograms cancel out, and we're left with grams. So that's going to give us 171 times 0.4536 times 1,000, which is 77,565.6 grams. Okay, now we're going to have to convert 1 foot cubed into centimeters cubed. So we have 1 foot cubed, and we're going to first convert this into inches cubed. So we have 1 foot cubed. Remember, we have to cube the 12 and the inches cubed. And then we're going to have to look at our sheet again. And we see that 1 inch is 2.54 centimeters. So we have 1 inch cubed and 2.54 cubed centimeters cubed. And then we're going to solve. So we have 12 to the third times 2.54 to the third. This is going to give us 28,316.8 centimeters cubed. So now we're going to divide these two numbers. We have grams now and centimeters cubed. So we're going to take our 77,565.6 grams divided by 28,316.8 centimeters cubed. And this is going to give us 2. And since we have 3 significant figures with 1.50 and 4 with the pounds, we're going to go with 3 significant figures. So that's going to be 2.74 grams per centimeters cubed. Now you notice this is different from the density of Earth. This disproves our hypothesis that the Earth is entirely granite. Before you guys work on the density worksheet that's on Google Classroom, is I want to look at 2 of the back of the worksheet, and then you guys should get started. So here for number 9, if you guys remember from Earth Science, you guys in Earth Science did a lab where you had some objects and you need to find the density of it, and some of you, those you did by water displacement. So if you have a sample of lead, a metal, and you use a graduated cylinder, you can imagine you have a graduated cylinder and you have water in it, and then when you put the lead into it, the water is going to rise, it's going to go up, and you can tell the volume of that lead by the displacement that you see with the water. So that should help you figure out the volume with number 9. And with number 10, if you find the volume of a cylindrically shaped object, this one, think about with math class, if you have a cylinder, to find the volume of that cylinder, you would look at the height, and you would also need to know the radius. We have the diameter, so we can calculate the radius, and the formula for the volume is height times pi r squared. So once you know that, you can then use the mass and find the density. Okay, so good luck on the density problems, and email me if you have any questions.